Hey guys, welcome to the Real Number System Slides walkthrough video. This assignment was a little bit trickier than I anticipated it being, so I wanted to make sure that I made a video for you to do alongside with me or for you to check your answers, okay? All right, so here is the little funnel diagram from our notes. So I'm gonna go over the different types of numbers real quick, so as a refresher, okay? So real numbers are all types of numbers that you've seen in your life. And all those numbers, there's a lot of different types of numbers you've seen, can be categorized into one of these groups. Irrational numbers are numbers that are irrational. They don't make any sense. Okay, they go on forever. The decimals go on forever. There's no pattern. There's no rhyme or reason what the decimals are. Those are irrational numbers. Okay, and then over here, I'm going to start from the top. Natural numbers, aka counting numbers, are numbers. Well, think about it. When you were little and you learned how to count, what did numbers look like? 1, 2, 3, 4, 5, 6, 7, and so on. Okay? You don't see a little 5-year-old saying 1.1, 1.2, 1.3, right? Okay, so think of those counting numbers. When you first learned how to count, those are the numbers. Positive whole numbers. Now, a whole number, okay, if you drop the marble down natural, it drops down the whole. Whole also includes 0. That is the only difference. Okay, so whole numbers are all those natural numbers, 1, 2, 3, 4, 5, 6, 7, and so on, and 0. Okay, all right, the marble's coming down also hits integers. Integers are all whole, positive and negative numbers. Okay, but integers are also natural, they're also whole, so we still have the 0, 1, 2, 3, 4, 5, 6, so on, but we also now have the negative numbers. -1, -2, -3, -4. Still whole numbers though, okay? Rational numbers are all of those funnels above, so all those negative and positive integers, all the whole numbers, 0, and it also includes decimals that end. Something like, I'll go ahead and use one of these examples. Something like this, 0.98, period. It ends. Okay, decimals that end. And it also includes proper fractions. Something like a fourth we know is a quarter, which is 0.25. That decimal ends. Okay? And it also includes mixed numbers. Something like 3.5. That's 3.5. It ends. Or like a third, it repeats, but that's okay too. Okay, so it's going to be repeating decimals. 0.333333 repeats, but there's a pattern to it. Or 0.12121212, it repeats, but there's a pattern. Decimals that end, and proper fractions. Okay? All right. I think the easiest way to go for this assignment is probably to go ahead and highlight our irrational numbers. Irrational numbers are going to be red. These are the numbers that go on forever with no pattern. Okay, can you find them? You might pause this video if you want to now and try to find them on your own, but I'm gonna go ahead. Pi goes on forever, you guys. Pi's actually, that's what makes pi really, really cool, is that it goes on forever and there's no pattern. It keeps popping up in real life, dealing with circles, which is just wild. That's crazy. Pi is a natural phenomenon. Okay, and then also this decimal right here, you see that dot, 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 that means it goes on forever. Okay, so those are our irrational numbers that I see right away. I'm also gonna go ahead and simplify some of these guys. Okay, 0, that looks fine. This one, -3/4, I'm just gonna go ahead and write, I know that that's negative 0.75. Okay, just another way to look at it. Make that a little bit smaller. Okay, this bar up top, in case you don't know, that's the repeating bar. So that is sorry, this car is so loud. 4.3232323232. So it repeats. Square root of 60. I don't know that off the top of my head. That is not a perfect square. So I'm going to pull up this Desmos calculator on my phone. Did you know Desmos has an app? You should get it. Okay, square root of 60. I got my answer. You could plug this into the Desmos tab, the Desmos calculator. I got 7.745966692. That doesn't seem to be a pattern at all. So actually that one's also irrational. I'm just going to go ahead and highlight that. This is red. Okay, can I simplify anything else? 3.5. I'll go ahead and write that one. 3.5. What else? Oh, square root of 121 right below. Do you know that? You should know that. What number times itself is 121? 11. 8/3. You can use your Desmos calculator for this, or you can rewrite it as a mixed number, and when you do that, you should probably know what it is. That's going to be 2.66666 repeating. So that one does repeat. That one does have a little bit more of a pattern. Or as a mixed number, that's 2 2/3. 8/4. Ooh, this one's a tricky one. It looks like a fraction, but 8 divided by 4 is really 2. That's a whole number. Okay. I think that's it. I'm going to write some equal signs. Okay. All right, so now we're moving on. Actually, you know what? I think I'm going to go box by box and see where it goes in this funnel. I think that's going to be easier. Okay, 0. Where does 0 go? 0 is not a counting number. Okay, counting numbers are only start at 1. 1, 2, 3, 4. But it is a whole number because whole numbers are those counting numbers as well as 0. Okay, so 0 is a whole number. And if I threw my marble into the whole number funnel, it'll hit integers, rational, and real. So we are going to color this one. Which one's whole, integer, rational, and real? Rational, integer. So green. This one's going to be green. Okay, does that make sense? If I threw my marble into whole, it's going to hit integer and rational. So it's going to be rational, integer, and whole. All right, next. Negative 0.75. That's a decimal. So I'm going to automatically go down towards the bottom of my funnels. That is a decimal that ends. So it's not irrational. It's a rational number. Okay, so let's see. Rational only. That's going to be orange. Okay, I'm going to keep going. 4.3. That's a decimal. So it's either irrational or rational. That is a repeating decimal. 4.323232. So there is some pattern to it. So it's going to be rational. Also orange. This is not an integer. I know you know that. It's not a whole number. So it can't be any of these upper funnels. It's just rational. This is another decimal that ends. You know what that means? It's rational. Here is a massive whole number, though. It's not a decimal. It's not a fraction, so it's not rational. Well, it is rational. It's included in rational, but we can keep going up in our funnel. We can be more specific. Is it an integer? Yeah, that's a whole number. Is it a whole number, 0 and positive? Yes. Is it natural? Yes. I can't imagine a little 5-year-old counting past 10, but they could. So this is also a counting number. So we're going to put our marble in natural. It's going to go hit whole, integer, and rational. So it's all of them. That's going to be blue. 1,000. Okay, so start as a decimal. Okay, move up. It's an integer. It's a whole number because it's positive, and it's natural because it's a counting number. Negative 5.45. That is a decimal, and it does end. So that one's going to be rational. I know when I do this, it makes it seem so easy. And when you do it, it can feel a little bit tougher, but you're doing great. Square root of 121, which is really 11. Okay, that's an integer, I know. That's a whole number because it's positive. It includes 0, and it's a natural counting number. A little kid can count to 11. So that one's going to be blue. It's all of them. 8/3 equals 2 2/3, which is a mixed number. That could be rewritten as a decimal, 2.66666. So is it rational or irrational? It's rational because it does not end. Sorry, it has a pattern. It's not random, totally random. Negative 4. Oh my goodness, my computer's gonna die. Negative 4 is an integer because it's negative. It's not whole or natural because it's a negative number. Okay, whole numbers and natural numbers are positive. So this is a negative integer. If I threw the marble into integer, it would also hit rational. So it's integer and rational. Integer and rational. Yellow. This is our first yellow one. Whole number 2. It is positive. It is a counting number, which means it's also going to be integer and rational. It's going to be blue. Okay, we have this decimal right here, 0.98. It ends, so that means it's going to be irrational. Oh, sorry, that kind of looks like that was like a mix between orange and yellow. There we go. Well, okay, that's orange, okay? And then negative 47, that is an integer. It is not whole because it's not positive. It's integer, and marble drops down, also rational. So integer and rational. Yellow. Okay, that is the first slide. Hopefully that makes a little bit more sense doing it along with me. I'm going to move on to the next one. Okay, slide 2. Check marks the spot. Determine the correct classifications for these numbers. We're pretty much doing the exact same thing we just did, but instead of colors, we're using check marks. You can copy and paste this little guy into each one of the boxes if you like. Okay? All right, so here's our funnel: rational, integer, whole, natural, and irrational. This is already put in order, so know that if it's the further to the right besides this irrational, okay? If it's natural, that's all it's going to be. If it's in, oh, it's not in order. Rational, oh, sorry, natural. Oh my goodness, I made a mistake. Okay, if it's rational, that's all it's going to be, because if you drop your marble in, it's just going to be rational and real. If it's an integer, it's also going to be rational. Okay, so you're never going to have a check mark only in integers, because it's also going to fall and hit rational and real. If it's whole, it's going to be whole, integer, and rational. If it's natural, it's going to be a natural, whole, integer, and rational number. Does that make sense? Okay, so if the further right you go in this table, you're also going to hit all the things before it, if that makes any sense. Okay. I think it's easiest to go ahead and do our irrational numbers. Irrational numbers do not repeat. They're random numbers that go on forever. So this first one, see that dot? No repeat bar. That's irrational. That one looks okay. Square root of 16. You know what that is? 4. That's 4. You should know that's 4. Okay, negative 1 and 4/5. That looks okay. 0 looks okay. Square root of 50. Don't know the square root of 50. Let's pull up my Desmos calculator. Square root of 50, I got 7.071067812. Nah, that is a bunch of random numbers. It's irrational. Okay. All right, so now let's see what we have. Negative 1,283,903. That's not a decimal. Okay, so it's not rational. Well, I'm sorry. It is rational, but we can be more specific. It is a negative whole number, which means it's an integer and rational. That's it. We can't get more specific. 4. Whole number 4. It's an integer because it's a whole number, but it's also positive whole number, and it's also a counting number. So it is all of them. It's natural. Marble drops down to whole, integer, and rational. Negative 1 and 4/5. That's going to give you a decimal. That's negative 1.8 if you know your benchmark fractions or you use Desmos. It's negative, however, so it's not going to be whole or natural. It's also not an integer because it's not whole number. So rational. 0 is not a counting number. Okay, counting numbers start at 1, but it is a whole number, which means it's everything below. It's whole, marble drops to integer, and rational. All right, there we go, slide 2. Of course, if you have any questions as I'm completing these, please send me a message. Okay, and like I always say in all my videos, I know I go pretty quickly, but that's the cool part about videos is you can watch them over and over and over again, so you can go back if you need to and watch it again. All right, this one we're going to circle the statement. So I put a little circle right here. You can just make copies of that circle and drag it over, or you can highlight it or do whatever you want to do, as long as I can tell which one is always, sometimes, and never. Rational numbers are integers. Let's look. Rational numbers, if I threw a marble in here, it would fall down. It would never hit integer. But an integer could be rational. Okay, so this one's going to be sometimes. All right, because an integer, if you threw a marble right here, it would fall down and hit rational. The only time it's never is if we try to go from the left to the right. Okay, irrational numbers will never be any of the ones on the right. These numbers on the right will never be irrational either. Okay, actually, let me put this little, here, I'll just write it right here. I put this in your notes as well. Okay, here we go. Going up the funnel is sometimes, because a rational number could sometimes be an integer, because an integer could fall down and hit rational, but not always. Going down will always be the case. If I threw a marble into natural, it will for sure hit whole, integer, and rational, no matter what, because it's falling down. And never will be going across. Okay, so hopefully this little try right here will make things easier. So let's try this again. Rational numbers are integers. Rational, integer, that's going up sometimes. Irrational numbers are rational numbers. No, because that's going across. Irrational numbers will not be rational. That's never. Natural numbers are whole numbers. Natural, whole. That's going up. That's sometimes. Sometimes it could be. Integers are irrational numbers. Integers are irrational. No, because that's going across. That's never. Whole numbers are integers. Okay, so if we start at whole, yeah. No matter what, whole numbers is going to hit integers on its way down. So always. Irrational numbers are whole numbers. Never. Irrational numbers are never anything else. Okay, it's all by itself over there. Integers are rational. Integers are always rational. Rational numbers are whole numbers. Rational numbers up to whole, sometimes. Okay, so if you're good at reading this funnel diagram, or your Venn diagram, if you prefer the Venn diagram, then this slide shouldn't be too bad. Okay, click and drag each item to the correct location on the Venn diagram. Oh my goodness, how did I know? I just mentioned Venn diagram. So the deeper in a Venn diagram, now this is like a square shape. Sometimes your Venn diagrams are circle. I say most times they're circle. The deeper into your Venn diagram you get, the more specific your number, okay? And honestly, I prefer the circles over this because this kind of looks like this section looks like it could be part of this one, but I believe that's one section, that's another. Okay, so irrational should be over here by itself. And then within irrational, you have, or sorry, not within, you have irrational, and then you have rational. Rational is going to go on the outside, and we can get more and more specific. So a special kind of rational number is a integer. Okay, a special kind of integer is a whole number, and a special kind of whole number is a natural number, a counting number. All right, there you go. I'll put this down here. It's a little bit more of a pattern. Because a natural number is inside the whole number box, which is inside the integer box, which is inside the rational number box. Okay. All right, so let's sort these. Oh, there's pi. I know that's never ending. That's going to be irrational. Let's see. Natural numbers are counting numbers, so all positive whole numbers. Oh, okay, now that's positive whole, but that also includes 0, so we don't want 0. Because 0 is going to be a whole number. That's the only difference, remember, between natural and whole, is that 0. Okay, integers are positive and negative whole numbers. That's this one. And then once you start dealing with fractions and decimals, that becomes rational. All right, there you go. I hope this video was helpful. I feel like I was talking really fast, but go watch it again if you need to. Bye, guys.